What's up, guys? EnderUnknown here. I'm back for the first episode of my 2D Unity Spelunky-like or Spelunky-style game tutorial series. So I guess before I get started, a quick disclaimer is this is not a Unity or C# tutorial, basics tutorial, I should say. Uh, I'd really appreciate if you had a basic understanding and would recommend a basic understanding of both Unity and C# before starting out with this. As I'm not going to be explaining every little part of Unity or every little C#. I will explain, though, what I am doing at the given time to the best of my ability. Anyways, with that out of the way, we are going to get started today with terrain generation. And to do that, I have set up a scene and inside of this new project that I'm calling the Corrupted Caves, because I had to come up with something. I'm not good at naming things. So, yeah. Mm, okay, so yeah, I imported my sprites folder from my channel update video with the knight and the knight player sprite map and our tiles and such. So yeah, we're gonna get started by making a prefab for the ground tiles. We're gonna start by dragging this into the editor, and I'm gonna make the camera go away for now so you can see this. This is our tile. Now, something doesn't look right here. We actually have to change our import settings. So what you're going to want to do is change this filter mode from bilinear to point, and that sharpens it up there. And then also you're going to want to change this compression to none, and then apply, and then that should fix it. Now, I guess it does change the look based on how you do this. Like, the normal quality gives it a little more texture. I honestly have no idea what's going on with that. Uh, I think it makes my art look better, but I'm just gonna go with none. So, yeah. Anyways, back onto our little ground tile thing. I'm actually going to name this basic tile because that is what it is going to be representative of in our game space. We need to size it because for whatever reason, a scale 1 item isn't the same size as this grid, and that doesn't make a lot of sense to me. Maybe it's because the texture is small. I really am not so sure with the whole Unity thing. Uh, Anyways, I think this is a 32 by 32 sprite. I'm sure I could find that out somewhere. Maybe pixels per unit probably uh, actually is something we could change to make it bigger. So if it is 32 by 32, we apply that. Yeah, well, there you go. So I guess just change it to the resolution of your tile. The other solution would be is to scale it. So I'm going to just leave it like this. I am using the transform snap to grid tool. So if I duplicate this here, I can just snap it to the grid, and that's kind of how our tile system is working right now. We don't really need that. The only thing we're going to need on this basic tile right now is a 2D blocks collider, and that is just going to make a collision box around this asset here, so our player is going to be able to stand on and jump on top of it and collide with it, along with enemies and items and whatever else ends up getting added. So yes, that is pretty much all that we need to do, aside from making a new folder called prefabs. I'm going to drag basic tile into the prefabs folder and then delete it out of the scene. So now we have a prefab of it, and we can programmatically edit it or apply it into our scene here. Finally, I'm going to create another folder, and we're going to call this script, and this is where our C# stuff is going to go for programming. I'm going to create a C# script called probably, I say world generation, but it really is not a big, expansive world, so I guess we could call it dungeon. I don't know. I'm just going to call it generation. And then if you double click that, it will open up in Visual Studio. I'm just going to skip ahead in editing so that you don't have to see Visual Studio load, because that is sometimes takes a long time if you haven't if you're not running it in the project. So yes, I will be back when that is loaded, and we will continue on with the programming. Okay, so yeah, we got our two methods here, start and update. I already removed the documentation text. I'm going to get rid of both of these here, and we are going to get started by defining some variables. So the first thing we're going to want is our length and our height. You guys can, of course, do whatever lengths and heights you want, and we'll change this in the editor. I'm going to be doing 4x4 to mirror Spelunky's style. I'm pretty sure I'm going to do my best to make sure that this is all like I use variables, and the variables matter more than hmm, the variables matter more than the specific numbers themselves. So it'll work whether you type in whether you do a 5x5 or whatnot. I guess I will say that you probably can't do a 1x1 or whatever. I don't know how that would work. So yeah, again, I'm going to be doing 4x4 with a block scale, which means 10 block or the number of blocks per room. So I guess the X and Y number of blocks. It's not total, so I guess it'd be 100 blocks. I'm not doing a good job explaining this, so sorry. Yeah, my scale is going to be 10. Again, I'll update that in the editor. Essentially, it's the how many blocks long and how many blocks tall, length and width of a given room. Yeah, so we're going to need some prefabs, and we're going to get started. How I'm going to be doing generation with this is it's going to generate a bunch of nodes, and then each of the nodes are going to generate the actual rooms. But there's going to be a stage where the nodes can be shifted around to make sure that the generation is smooth and clean. So yeah, to get started with that, we're going to make some game object array. This is going to be starting rooms. Currently, I'm only going to have one room, but I might be doing more with this later, so I guess I'm just going to be adding it as an array for now, so we can build upon it maybe later. So we're also going to be making another game object array called path rooms. These are going to be the specific rooms that are going to be connecting our start and the pathway down to the finish. A little note that is always helpful to leave ourselves would be is I'm going to be using numbers to represent everything, which makes sense because we're using arrays. So the 0 slot is going to be a left-right corridor. The first slot is going to be, or iteration 1 on the array, however you want to phrase that, is going to be the left, right, and bottom. 2 is going to be the left, right, and top. And finally, 3 is going to be the left, right, bottom, and top, so the omnidirectional one. We might add more to this later, but currently that's all we're going to need to be constructing our most basic program. Next, we're going to want to make another array called filler rooms. I'm not going to be doing too much with this, like the filler rooms this tutorial, but we will be getting into those in a future video. Right now, we're just going to have it so that they generate, but nothing specific. So yeah, then we also need to get a game object called ending rooms. And this is like starting rooms. It's an array of possible rooms that the end could occur in, and that will be the exit door, which will also be worked on in a different video. Yeah, so those are kind of our basic, I guess, Unity inspector, editor, whatever you want to call them, variables that we're going to be using to control our world generation. A couple other things we are going to need is a two-dimensional array, which is annotated with a comma here, like so, called room array. This is going to be a list of our rooms and their respective positions. We're also going to need a list of vector2s, which is going to be called loaded rooms. This is so that we can differentiate which rooms need fillers. So we're going to generate the pathway, and then all the other rooms are not going to be in this list. So whatever coordinates are not in this list is where or are the locations that are going to get a filler room generated at. Finally, the last thing we're going to be doing is a integer that's going to represent our delay time. This is just something that I find interesting to watch the room generate. If you set it to 0, it's going to generate as fast as the computer can process it. I don't know, this might be a interesting feature to play around with. I'm going to include it because it's easier to have now than add in later. Yeah, so we're also going to want a Boolean value that is going to be accessible from other classes here. We could hide this in the inspector by doing this. I really don't think that matters too much, so I'm just gonna leave it the way it is. So basically, this is gonna be the flag, if you will, that's gonna be like, hey, we've got the first step of generation, which is placing the nodes. The second step is going to be generating the rooms. And then the third step will be spawning the player. Actually, the third step will be spawning loot, and then the fourth step will be spawning the player. Loot and enemies, I guess. Something like that. I'll figure it out. We're also going to want to int direction and a delay as well. Delay is going to equal 0 by default because we're going to be using it as kind of a timer. Pretty much that is it. The last thing we are going to want is a seed. So this will actually be a public int seed. This is what we're going to be allowing the players to select from to generate a configuration that's always the same. Or of course we'll have random seeds. That will be figured out in a later video. We're just going to add the framework for it. That is all of our variables that we're going to need. So we're going to start by making the start method right here. So let's just void start. Yeah, so the first thing we're going to want to do is initialize our room array. And to do that, we just need to do room array equals new game object, game object 2D array with length and height. So our length value and our height value. And for the seed, we're going to get the instance of random. I think they changed this. It's now init state or initiate state, and then seed. It used to be random.seed in older versions of Unity. So yeah, that's going to be setting the seed based on what we set up here, which will also change in the inspector and have a menu that players will be able to select their seed or do random. I don't know how we're going to figure. I don't have plans for that far out for a menu. I don't really know what we're going to do, but I will definitely figure something out. So yes, now what we're also going to need to do is set the transform of this, or transform position, sorry, is equal to a new vector 2, and it is going to have, okay, so I should probably explain a little better. Basically what we're doing here is getting a random value, and this is going to be the starting room. So the position of our game object here is going to be representative of the room grid, not actually its physical space in Unity doesn't matter. It's the vector 2 position that it represents for the rooms. And it's an interesting way of doing it. It's kind of more abstract. I hope it makes sense. So yeah, this is gonna set and randomly, or select and randomly set the position of the game object so that it can be then that position for the starting room. Then of course we are going to need a way to create rooms, so I'm going to start by making just a simple create room function. I'm just going to call that void create room for lack of a better name. This function we're going to pass in a game object called room, which will be one of our templates. Inside we're just going to get a game object variable called temp, and that is going to equal instantiate, which is going a function that creates stuff into the Unity world. It also will spew out a reference, and we're going to use this reference to store in our array, our room array. So we're going to instantiate the room that is passed in by the game object. We are going to instantiate it at our transform position vector multiplied by the scale. So what that's going to do is, and we're getting an error right now, but that's because it thinks I'm doing a different method. I guess, so yeah, the transform position multiplied by the scale is going to put the room at the right position in the Unity space, because like I said, the transformed.position is the representative. It represents what spot it is, so 0, 1, or yeah, so actually 0, 0 is pretty simple. Would be the top left, whatchamacallit, room. And then you multiply that by the scale, and I guess this is a bad example because that also equals 0, 0. But that means it's going to be putting that tile at 0, or not tile, that room at 0, 0. It's kind of hard to explain. It'll be better when I show you. So then the final thing is we're going to need a rotational value, which is just going to be quaternion identity. Quaternions are beyond the scope of this video, so maybe in a future video if they're pertinent. I don't think they will be. That's just the instantiate method requires one. So what we're also going to want to do is get the x and y positions from our transform position, because the transform position is technically a float instead of a integer. So we have to do a little conversion using a cast. Technically, we will be using transform. The transform is always going to be set to an integer number, but the game doesn't, or like the code doesn't know that. Unity doesn't know that, so we have to tell it in C#. So that will just be cast it to int transform.position.x. Now, here's where things get a little interesting, and just bear with me. We're going to be doing the same for y, but y is interesting in the fact that we're actually going to make it negative, or the opposite of the transform. So this is because in our transform is going to be moving down, because like I said, 0, 0 is the top left corner. Well, that means if we move down 4, so the bottom layer, that's going to be 0, negative 3. Because 0 is the first layer, negative 1 is the second, negative 2 is the third, and negative 3 is the fourth layer. Or fourth being the bottom layer. Well, because of that, the two-dimensional array here is going to work better if we just have it as a positive value. So we have to take the opposite of it. Again, a lot of this is more abstract, and I guess it made sense to me when I was making it, so yeah. So then we're just going to be getting our room array at x and y, and setting that equal to temp, which is a reference to our instantiated game object. After that, all we're going to have to do is add loaded rooms.add. We're going to have to add a new vector, vector2, xy, to our list of loaded rooms, and that is going to signify, hey, this room has been loaded. We don't need to put a filler on top of it. Anyways, back up to the start method. We have to do the actual creating of the room, the start room. So create room, and then we're just going to do starting rooms. We don't need anything random because there is only going to be one. Like I said, we might add more to this later. But yeah, starting rooms is just going to be at 0. So then we do have to do a little bit of, I guess, logical thinking here to prevent the room from going left if it can't go left any farther, or right if it can't go right any farther. Because I found that if the entire top layer, if it just goes down immediately and the entire top layer is unexplored, sometimes it just doesn't end very well. And I personally don't like spawning players on a platform where they can walk off and then go down. It's really awkward when making the tiles in the tiles for the rooms. So I'm just going to be adding a little bit of insurance to prevent players from, or the game from making players go straight down immediately. So again, this is quite simple. It's a little bit of a logical, I don't know, thought process. So if the position of X is equal to 0, or in other words, the room is on the farthest left-hand side, we're going to have to set our direction value equal to 0. Now, I maybe should add with direction, 0 and 1. 0 and 1 are equal to right, and 2 and 3 are equal to left, and then 4 is equal to down. Why, you might ask? Do I have two variables for each, or two numbers representing each of these, and only one for down? Is to make it more probable that the room generation will generate a room to the right or left than it is to go down. Because otherwise, you'll get a level where it'll just go down as much as it can, and then that's a boring level. I mean, you'd probably die of fall damage. Again, I have later, when we get a little farther, I'll put in some stuff that will prevent it from generating more than, I don't know, 2 consecutive downs in a row. So it's not like, hey, you'll spawn in, there's just one straight pathway all the way down to the bottom, the player falls and dies. Because that's not fun. Anyways, continuing on, we have to do the same check for, to make sure that it's not on the right-hand border. So if position X is equal to the length minus 1, so the length is 4, 0, 1, 2, 3. 3 is the fourth position to the right on the grid, so that's how we get that value, length minus 1. If that is true, I guess we don't need curly brackets there. The direction is going to equal 2, which is significant of left. So if it's on the far right-hand side, it's going to go left, and vice versa if it's on the far left-hand side. Otherwise, if it spawns in one of the two internal, why do I keep making these? If it spawns in one of the internal two parts of the room grid, it really doesn't it really doesn't matter. So we generate it by random. So it'll just be between random range between 0 and 4. So I guess we could do 1 and 2 and then convert it to the other way, but that doesn't make sense. So that is all we need in our start, like our actual start method. We are going to have to start continuing on with the update. This is going to be a loop, so it's called every frame, I think. Update. So we have to do some checking because we don't always want it to update. We actually want to do a quick check here. So if the first stage is not done, so first stage done equals false, and the delay is greater than or equal the delay time, then we're going to want to be doing all of our like adding in the world pieces, however you want to put that, spawning in the rooms. And otherwise, we're just going to want to increment the delay. So I guess else is delay plus plus. So pretty simple. Again, the delay system is just easier to add now than later. Anyways, the first thing we're going to do is reset that delay counter. So delay is going to equal 0. And then now we just have to get into the nitty-gritty of the logic-based stuff. So if we're doing a right, what do you want to call it, right motion, or if the direction is equal to 0 or the direction is equal to 1, in other words, we are going right, then we have to do a couple more checks. So a lot of this is all check-based. We have to first make sure that the same condition up here doesn't happen, because if it's going right, or just if it's trying to go right but there's a wall there, it has to go down, or the edge of the map being a wall, edge of the level. So for checking that, we just have to do another if statement with transform.position.x. If that is less than the length minus 1, so pretty much the same check that we did up here, just it's making sure that it's less than, it doesn't care if it's equal to, then this is going to mean we're going to just create the room like normal. Otherwise, we have to set the direction equal to 4, and that is all we have to do because we will handle that in a separate part of the code that is like, hey, direction 4, that's down, we're going to move down. But right here, that's not applicable, so we are going to continue on by starting with moving our, the game object, the generation game object, to the right to signify that it is in a different spot. Vector3.right is just shorthand for this vector that you can see on my screen. It's an interesting way to write it, I guess. So we're just adding vectors together, so pretty simple math here. Technically we're working with a vector 2, but it does not like adding a vector 2 to a vector 3, which makes sense. So that's the first thing we have to do, is move the position of our I call it the head, I don't know why. I'm thinking of a Turing machine when I say this, a Turing machine that writes and edits rooms. It kind of functions similarly. I guess if you don't know what a Turing machine is, you should Google it. It is a very primitive form of computer, but it can actually do some complex stuff, which is cool. So yeah, I guess however you want to refer to this. Anyways, aside from that tangent, we are going to have to set our random number to 0. So basically, this will make sense here when I do create room. We're going to be creating a path room with R. Now, this doesn't really make sense now, because if we go back up, R is a hallway, basically, a left-right hallway. Which means it has openings on the left and on the right, but it's closed on the top and the bottom. I don't know what we're going to do, if anything, with this, but I figured I'd give myself a integer, so we can always change this later with, like, random number generation, instead of just saying path room 0, which that would technically work, but for simplicity and ease of access later, this is how I'm going to do it. Again, it's not really important now, it's just we might use it later. I really don't know. Anyways, yeah, so we're going to create the room. So the process is we move I keep forgetting, generator game component to the right. We create the room at that new position, and the position converts the transform of the generation game object into the actual room Unity world coordinates. And then we have to get a new direction. So we're going to set direction equal to a random range between 0 and 5, so it can go in any direction. Now, however, we have to consider that if we go look at our key up here, if it's going left and it just came from left, well, it can't do that. That doesn't make sense. So we have to write in a little rule here that if direction... So, okay, I didn't explain that very well. We move to the right when picking a new direction. If we move back to the left, we're just going to overwrite it, which doesn't make any sense. So we're adding code that prevents it. So if direction is equal to 2, which is going to be left, instead we're going to set it equal to 1. Direction is equal to 1. So that's going to mean it'll go right instead. Else if direction is equal to 3, we're actually going to have it go down. So this equals out, I think that means 3 numbers are pointing towards right, and then only 2 are pointing towards down, to encourage the computer to create more horizontal levels than vertical levels. Anyways, that is all we need to do for our right-hand side. Pretty much, it's almost identically the same for making the thing move left. I'm gonna kind of just go through this really quickly. So now it's just else if direction is equal to 2 or direction is equal to 3. In other words, left. Left, I can spell sometimes. Then of course we have to do our logic thing, so transform position x. Instead of checking if it's less than the max, we have to check if it's greater than 0, because 0 is the minimum slot that a room could be in. Again, if it is unable to, we're just going to set direction equal to 4, so it'll go down. This is pretty much the same. I'm almost tempted to copy and paste this, but I guess I won't because, yeah, it's just confusing copying and pasting things sometimes. So I'll just write it out pretty quickly. So, yeah, it's almost the same. Instead of right, we're going left. This is all the same here. We're going to be not creating an asset menu, creating a room at, oh, my dog just came. Hi, buddy. Okay, anyways, sorry. We're going to be creating a path rooms 0, not 0, R. I created R for a reason. Don't question. We're going to also be setting our direction equal to random range, not random range, equal to random dot range between 0 and 5. And then off of that, we just have to do our quick, if it's going to go right this time, it doesn't make sense that it would go right after it already went left, because it would overwrite itself. We're setting the direction equal to 2, and the same is true. Direction is equal to 1. So 0 and 1 both equal left, then we're just setting it to go down. Okay. Oh, and silly me. Only single equals there. Hope you guys caught that. As I did not immediately. So now we have the final direction, which is down. And I might add that this video is probably going to be a little longer than I'd like it to be. I don't really want to break it up. We're going to do first stage generation today, and then we'll do probably second stage next week, and then player, and we'll go off on some other stuff and finish off the generation. But I guess that doesn't really matter now. And then finally, if the direction is equal to 4, in other words, down, we have to do more checks, of course. Transform. Now this one we have to check the position of y instead of x, and we have to make sure that that is greater than the opposite of height, because like I said, we're doing the confusing thing where the position is going down instead of going up, because it writes top to bottom, but the top value is at 0, so the bottom value is going to be -3 or whatever. So then we just have to add 1 to the height here, and then so this is it's doing the same check. It's making sure that we're not in the bottom row, because if we're in the bottom row, other stuff happens. That other stuff is, I'm going to write at a later point here because it is a little more complicated than the previous ones. We don't just set the direction equal to 4. Yeah, so before we continue, we need to go write another method called, I don't know, getRoom, kind of boring names. So GameObject is what it's going to return. GetRoom, we're going to pass in a vector2 called position. And then all we're going to return is our room array with casted to int position x, and then the opposite of our position y, also casted to an integer, and that is going to return a room at any position that we ask, if one does exist. So we actually have to destroy a tile. So if you think about it, I'm trying to explain this. I can visualize it in my head. Maybe I'll be able to get some pictures up on screen that help. I don't know if I'm gonna have time to do all that editing. Um, if it needs to go down, say we have a left-right corridor, and then now it needs to go down, we have to replace that left-right corridor with the left-right corridor with the bottom opening. So to do that, we have to destroy the pre-existing one, and that is why we are making that git room. We have to get the room at our current, or get the room at the position of our generator in the room array, which has nothing to do with the Unity array positioning system, or whatever. We destroy that, and then now we have to generate a random room, and that's going to require a little interesting quirk, I guess, that came up when I was writing this initially, is I didn't put the... So if we go look up here, I didn't put the bottom, the two rooms that had bottom on them together, so we have to do we have to generate a number between 1 and 2. So it's either bottom or omnidirectional. So left, right, bottom, or omnidirectional. And then based on if this is equal to 0, then we're going to use... I actually don't even know what this expression is called. It's like a flip-flop in the code line. I consider it just a inline if statement, but anyways, if it's equal to 0, then we're just going to choose 1, which signifies left, right, bottom. And if it is equal to, or if it's not equal to 0, in other words, it's equal to 1, it's going to be the omnidirectional. Now, what this is going to do is add more randomness. It really doesn't matter, because functionality, they both have a bottom opening. Anyways, we are going to create our room based off of that using our path rooms with R. Then, of course, we have to move our... Okay, I should explain this more again. So, if you think about it, we just changed the top one. Now we have to move it down. And then, based on how it's moved down, we might have to do some extra configuration, and that's what this is all going to do. So it moves down and it creates another room here. Now, there's going to be some quirks, and I'm going to show you guys, how to make or how it's going to prevent it from going down more than twice in a row. But anyways, we need to start by moving down the position, so we're going to just add a vector 3 down. Then we're going to make a variable, or an integer variable called rand, short for random. This is going to be a range between 0 and 4, so technically it's 0, 1, 2, and 3. This is a percent. I'm using this to get a percent. So if the case of random is equal to 0, or 25% chance, theoretically, of course, it's pseudo-random, so there's pretty much no chance to it. In fact, there is no chance to it because it's based on another thing. And that's a story for a different day. Anyways, back on topic. This is going to mean that it goes down twice, because we don't want it to go down twice frequently, but we want it to be a possibility. And of course, you guys can change these variables if you like. We have to repeat the check from above to determine that we're not on the bottom level, because if we're on the bottom level, then we have to do other things. Specifically, believe it or not, set the direction to 4, and then return, so none of the additional code is called. And what this will do is it will go back up here. So if it fails this check, on the next time it comes through, it'll say, hey, directions 4. This is the same check as down here. It's going to fail this one, and it's going to go to our else down here that I haven't made. And then that's going to be putting the finish line in and then generating filler rooms. When I say finish line, I mean the exit, or however you want to put it. However your games are, maybe if you have different themed games, I don't know. Mine's just going to be a door, probably, like Spelunky's. Anyways, back to our positioning here. What we're going to do is, if it can go down one more, it's going to create that room. And that is going to be a, like I said, it's going down twice. So this has to be an omnidirectional room because it needs a top opening for the room on top and it needs a bottom opening for the room that's going below it. So yeah, I don't know. I'm trying to explain this. It makes more sense in my head and I'm really struggling to explain. I'm sorry. I think my headset just turned off. It likes doing that these days. I really need to get something fixed with it. I might need a new headset. I don't know. Anyways, yeah, we're gonna move it down once more, and that is all we have to do because everything else is handled. Now, regardless of if we move down twice or if we only move down once, we are going to be using this code here, which is going to be to create a room, and we're always going to be creating, at the bottom of any drop, we're going to be creating a left-right top. There's nothing else that it would, actually, yes, I guess if we wanted, we could make it random, and we could have a left-right bottom as well. So, I guess maybe I'll do that here. It's a easy change. It's just int r is going to equal random. Oh, have I already used r? Yes, I already have. So we're gonna do r1. Ha ha ha! Beating the system. Range between. I guess. What is it? I think it's 2 and 4. 2 and yeah, because that would allow 2, 3, and 4 would be excluded. Yep, there we go. So, and then I guess we'll just make that r1. So yes, I guess that would also work. It doesn't have to be that. It really isn't gonna matter, I don't think, a whole ton, but, and I don't know. Like I said, so yeah, I guess I'll leave it for now. The same goes for the top here, where I don't know, I'm not gonna go find it, but wherever we have our, it could either be a top bottom, or sorry, not, yeah, an omnidirectional or a right bottom left. That should probably only just be a right bottom left instead of an omnidirectional. Same is true here. Ultimately, I don't think it really matters that much, so I guess it's up to your guys' discretion. Yeah. So now again we have to use that same check, and I guess for time I am going to go copy and paste it. We have to go all the way back up to our start method, and it's this check right up here. It's identical. So it's just the first if to the else down here with this. I'm gonna copy it. I'm double checking my script notes here just to make sure, yes, it is identical. And that just is gonna get pasted down here. Here's the code if you need it. You can pause the video if you don't want to copy and paste. I completely understand. So yeah, that is all we need to do for the generation of these rooms. Now the last thing we have to do is if it is the exit. So finally we just need to make one more else here. I guess this is going to be if a room cannot be generated. I don't know. If the direction, we don't need a note. It essentially, if it tries to generate another room down, instead it is going to make the end, presuming it failed the check that determines that it's at the bottom. So if it is at the bottom row and it tries to go down again, it's going to make a door instead of actually going down. So again, this is pretty easy. It's just destroy, and then we have to do getting a room at our transform position, and then of course creating a room, ending rooms 0, because again, I don't know when or if we're gonna add more than one ending room configuration. We're going to make a method called fillMap, and then the last thing we have to do here is set first stage done equal to true. And we're almost done. I know this has been a long video, and I've been talking fast, and this might be confusing. I'm gonna figure out GitHub. I don't know if I'm gonna have this first week posted, but definitely by the end of the project, I will have a GitHub. If I get around to it this next week, I'll add one and put the link in the description below. I don't know how GitHub works, so I'll have to figure that out. Anyways, the last method we have to make is called the fillMap. So that is just going to be pretty much filling up the last little parts that we don't have. Again, pretty simple in concept. Generate the rest of the room. That's a little note, I guess. So we're going to be using a nested for loop. So we're going to iterate through the y values. So y is less than height. I should really be using the auto generator. There we go. And then for tab tab. So if you press for tab tab, it's very convenient. So I'll just use X, press tab, and then length. We don't need to change that. So then the final thing we have to do here is check to make sure this room hasn't been loaded. So we have to do loaded rooms, which is our list of rooms that have been loaded. We are going to it'll be loaded rooms.contains, and then we have to see if it contains a new vector 2 with these x and y coordinates. And if it does, then nothing will happen, and if it doesn't, because we have this, it's called the inverse. It means inverse or opposite of, instead of exclamation point, but I guess for the sake of YouTube, I'll call it an exclamation point, so everyone knows what I'm talking about. We're going to get a room. So random range, not RNA, it's science lesson, not random range. Random.range, that bugs me. Why does it have random range? That I don't use that ever, or infrequently. Anyway, 0, and then filler rooms.length, so it'll get any of the filler rooms. We'll probably come back and add a weight system so that a treasure room is less likely than, I don't know, a room full of extra enemies. Not vex, new. I can spell sometimes. New vector 2, x, and then the opposite of y, because like I said, we're using that funky way to keep track of room coordinates where we don't use positive y values. We just use 0 through negative. And then finally, the create room, filler rooms, and then r. And congratulations, you guys made it to the end of the code. I know this took a little while. We have one last thing to set up in Unity, or one last set of things to set up, and then we are done, and we'll move on to some of the more exciting stuff next week. So I will be back when I am in Unity. Okay, I'm back in Unity now, and I'm going to be quick here. So we're going to create a empty game object. We're going to call it generator. We're going to drag our generation script onto it and start filling in some of these things. Length is going to be 4 for me at least, and height as well. The scale is going to be 10 tiles by 10 tiles per room. And then all these rooms we have to do stuff with. I'm not going to mess with the delay times. You guys can. Delay time is the one you're going to change. So if you want to delay, I found 100's pretty good if you just want to watch your room generate, but you don't want it to take ages. So I guess you can try that on your own time. Yeah, so we are going to have to create, oh, and the last thing, sorry, before we go create the prefabs is we need to put this to 0. And then I guess I'm setting this to -5 because the camera likes things that way. but it really doesn't matter, I don't think. If it doesn't work, let me know. -5 should work, but if you have it at 0. Yeah, so now we have to create the prefabs. So I guess if we look back in our Visual Studio, we have a start room. So I'm just going to name it start. I'm going to change the icon of the start room to this pink node here. And these are going to be nodes. So I'm actually going to call this start node. We're going to go into our prefabs folder. I'm going to create a new folder called nodes. And inside the nodes, I'm going to drag our start node. We will be doing more with nodes at a later point, but for now, that is all we need to do. I'm going to rename start node to, I don't know, left right node. We're going to change the color. That looks good. Left right node, enter. Going to drag it in. We're going to be prompted. We want to click original prefab because that's going to start or make it into a new one. We're going to want left, right, bottom as a node. I'm going to also change the color of that to red here. We're going to put that in as an original prefab, and pretty much we're just going to be doing the same thing for left, right, top, which I will make this cyany teal green color. I'm trying to do colors that I haven't used the same of. Oh, I can look at that. That's nice. And then finally the omnidirectional with it, which is left, right, bottom, top. And that is going to be yellow. Actually, I shouldn't say finally, because we have 2 more nodes we have to create. We need to create the end room node. So end node. That is going to be, I don't know, gray. Because it's the end and people are sad about the adventure being over or something. And then finally, we are going to create the filler node, which is going to be, sure. Did I use green? Did I use yellow? Did I use orange? I don't know. I guess I can look. I did use yellow. Well, I'm going to keep it with orange, I guess. So, yes. Then we're going to delete the nodes out of there, save our project here, and then this is kind of monotonous. I know it'll be hopefully a little better later down the line. But yes, we have to drag the node into this, like our start node has to go in starting rooms. Our path nodes have to be put in the precise order that we defined in our Visual Studio. So I believe it was left, right. I'm actually going to look. Yeah, it was left, right, bottom, left, right, top, and then the omnidirectional. So left, right, then we need left, right, bottom, and then we need left, right, top. Why do I have 2 of these with the same name? Weird. Okay. I'm gonna delete that one. This is supposed to be called end node, but I guess it didn't like me saving my thing, I guess. I don't know. Weird. So yeah, left, right, bottom, left, right, top. What is this? Oh, this is also supposed to be left, right, top. Okay. Left, right, top. We're going to delete this one. We are going to do left, right, top node. I don't really know what happened there. Looks like that's all of them, though. There we go. So left, right, bottom, left, right, top, and then the omnidirectional one, which is not that one. It should be that one. Left, right, bottom, top. There we go. That is all we need in our path, so 0 through 4, and then filler rooms. Like I said, we just have 1 for now. Like, these nodes are going to generate random rooms, so there's only 1. We might add different types of nodes for different types of rooms, I don't really know. And then finally, we are going to add in ending rooms the end node, not loaded rooms. End node. Okay, Okay, so now this all looks right. Yep, that should be everything. I'm going to get rid of this node that we have in the script. I'm going to save. And now it is time to press play. And there you go. So if you zoom out too far, the nodes disappear. But if you look, we have our starting node. We have a left-right. We have a left-right bottom, so that means the player could go down. Left-right top, they can go in here. This is a omnidirectional one. Another omnidirectional one, so I guess they can go down twice here. A left-right top, a left-right corridor, and then the finish line, or the end node. And then all the orange ones are just fillers. Now, I know this looks pretty boring, and I would definitely agree with you. It is quite boring right now. But once we start getting the rooms implemented, I think it's going to look a lot better. We're going to be doing that next week, though, because of time. So I'm pretty sure that's all I have for you guys. I guess, oh yeah, seed. If we change the seed, I'm not going to show it because this video is already really long. But you can change or play with the seed to get a different result. Anyways, this is all I have for you guys today. Thank you guys for watching. We'll come back next week and actually get the tiles into different types of rooms, so you'll be able to see what we're generating. I know we made the basic tile prefab already. I was really hoping we'd get to that point, but ultimately I kind of just ran out of time today. This took me a little longer than I had planned. And yeah, so we're going to come back next week for a kind of part 2 of the world generation for our second episode of the series. Anyways, I thank you guys again for watching, and Ender out.